Welcome everyone, and thank you for joining us today. Our OpenNTF webinar today for May 2023 is Understanding Collections, Maps, and More in Domino Languages. So we've got a application development oriented topic today. For fun, we've got Paul Withers back. So Paul has done our webinar in April this year and also in May. And along with Paul and myself, Jesse Gallagher from the board on OpenNTF is waiting in the wings to assist as we go through the webinar today. So you got the three of us. Very quickly before we get to the presentation, just a quick thank you to our sponsors. HCL has provided a financial contribution to make things go, and Prominic, of course, supplies all of our IT-related services, hosting, and other infrastructure needs, and we'd like to say a big thank you very much to both of them for supporting the community. And speaking of the community, as we always do, we encourage people to participate. And participation, of course, is not limited to making contributions in terms of code, asking questions, joining conversations, answering questions on Discord. There's lots of different things that we can do to support each other. And of course, I think a lot of the folks that have been around for a long time have learned some small thing from OpenNTF, and of course, whether that's inside your organization or elsewhere, probably pass that learning along. So even though you might think that you don't participate in the community from that perspective, you actually are by sharing what you know. And we encourage everybody to join in when they can, and certainly even asking questions or proposing ideas is a contribution as well. So please continue to do so. And most importantly, join the community on Discord if you haven't already. A quick note about things that are coming up. Next month in June on the 15th, in this time slot, we will hold our OpenNTF annual general meeting. It will be on Discord, and we'll share the information about how to be able to connect and join us, hear about things that have been going on this year, updates for other thoughts on things that we want to do in the coming year, and then certainly we encourage people's feedback in that regard to help us understand where we can best serve the community. So please plan to join us on June 15th. Our next Repair Cafe going to be admin topic focused, and it will be this time slot next week on Thursday, May 25th. And there's information on the OpenNTF website about how to join that. And then later towards, I guess, the middle of the summer, August 30th and 31st is CollabSphere. It's going to be in Chicago. I actually just bought my tickets the other day, so I will be there. And certainly for folks in North America anyway, encourage everybody to show up, and let's learn from each other there as well. A couple of quick notes on our next webinar. As I mentioned, for June, it'll be our annual general meeting. In July, we're back to security. Kim Greeny is a member of the OpenNTF board and also a longtime business partner with a focus on IBM I. She's going to come to talk about some Domino security best practices. All right, and just before we get into the presentation, a reminder to everybody that you're welcome to ask questions on the topic today using the questions panel in the GoToWebinar app on your screen. And we will answer all of those questions at the end of the presentation. We want to make sure that they can be asked and answered so that they're part of the recording that will ultimately go up on YouTube. Yes, this is being recorded and it will be available on YouTube, so we'll remind you to ask questions there. And you can also ask the chats in the chat as well, or at least the chat is a place for conversation during the presentation. Obviously, questions should go into the question panel so that they can be answered there. And we'll hold off on answering those questions until the Q&A section at the end. Okay, I will stop presenting and change to Paul. There you are. And you should have control now, Paul.
Great. Just trying to work out which that should be the screen. Hopefully you're seeing
that looks good.
Presentation. Yeah.
Off you go.
Great. So first up, this is probably familiar to many people. It's not here because I'm particularly religious. Back at university, I didn't do anything to do with IT. I did classics, Latin and Greek. When it comes to Latin, it's a bit of a challenge to understand what things mean because nouns have 5 declensions. Each declension has 6 cases: nominative, vocative, accusative, genitive, dative, and ablative, depending on whether it's subject, object, how it's relating to other words, so of something, and singular and plural as well. Adjectives then have 3 declensions, and again, each of those 6 cases and singular and plural. Verbs have 4 conjugations and 3 persons: first, second, third person, singular and plural. 6 tenses, so present tense, future, various past tenses as well, and 3 moods: indicative, how you're normally speaking, how you're normally using a verb; imperative, where you're ordering someone to do something; and subjunctive, where you would like to, where you would do something, as well as active and passive. So trying to work out what a word means is quite a challenge, and trying to work out how the sentence fits together. It's a case of looking for patterns, similarities, and differences, and things that you can definitively say have to be one particular noun or case or whatever. So patris, it can only be third person singular. It can only be genitive singular of the father. And that then leads you on to filii and sancti, both ending in I, both after an and. So again, of the Son and of holy, and the adjective there. And then you get something like spiritus. The obvious jump there is that US means that it's nominative singular of a masculine noun or adjective, except spiritus is 4th declension, and that means that the us ending is either nominative singular, nominative plural, accusative plural, or genitive singular. So it's a lot of this keeping lots of different balls up in the air, working out what each of the options could be, and working out how they fit together. So why is that relevant? Well, that's basically my day job with HCL now. It's to do with research. It's about working out how something might fit together, looking for similarities, looking for differences, looking how is this done in other areas, how is this done in other languages. So I've come from a background of working with LotusScript as a citizen developer, then learned some Java, since been working with JavaScript, and now developing VoltScript, and also doing some stuff with Rust as well. So there's a lot of similarities that I see with those languages, differences as well, things where certain languages have developed in a certain way and borrowed from other languages. And that's of particular relevance also for collections and maps, as we'll see. So what are we going to be covering here? So I'm going to start off with some non-collection objects and the kind of more basic options that there are with arrays and vectors. Then we're going to dive into all the various options with collections and maps and which ones to use when and where and why. Then streams. For those who haven't dived deeply into Java 8, one of the big things that Java 8 added was streams. They are extremely useful, extremely powerful, but also slightly confusing. So hopefully I'll demystify some of that. And then looking at collections beyond Java. So arrays. Arrays are just, so in Java, arrays are one-dimensional, zero-indexed, and a single type. That can be a base type, a base class for something, or it can be a primitive, for example, an int or a string. So how do we handle those and work with those? So that's the square brackets denotes that it's an array, and we can iterate those with a for loop, or if you want to step beyond the more basic syntax, the syntax that you would see from JavaScript, for example, then there's also the for each loop. And arrays we're also familiar with from LotusScript as well. They're also one-dimensional. They are also zero-indexed unless specified, either with defining what the bounds are for an array or using option base. And they're also a single type, but of course you can have a variant which can contain all sorts of different data types and objects. We've got the two types, fixed arrays and dynamic arrays. Fixed arrays, you define what the size is for the start, and you can just keep adding to them up to that size. Dynamic arrays, more powerful, but you need to redim them each time you add to them. It makes your code more verbose. But fixed arrays have some certain challenges to them. And at this point, I will jump across to Domino Designer. So here's an agent. At the global level, we can have all sorts of elements in there. We have much greater flexibility. But when it comes to a particular module, here we can see this is compiling fine with 3500. If I just change that, then here I've got 2100, and it gives me the error size of data cannot exceed 32K in the scope. If I have 2100 strings, it's fine. So different data types will take up different sizes. But it's a 32K limit, not just for each array. It's across all fixed arrays in that scope, in that sub or function. So now that we've got two arrays there, it's giving us the error because it's aggregating both. The other interesting aspect is if I just close this agent and run it, and it puts the agent log on the wrong screen, we can see that ran fine. It printed the hello world, which is after the actual declaration. Now let's look at what happens else on the server when we run it. So I'm going to bring up my browser as well, because I'm going to run this from the browser. So I'm calling that arrays open agent from the browser. If we run that, then you'll notice that that same agent, which ran fine on the Notes client, is throwing an error out of stack space. That's because 64-bit will allocate twice as much memory for each element in the array. So the 3,500 entries that works fine on the Notes, on the 32-bit Notes client, errors then on the server. So there are some quirks with fixed arrays that we need to be aware of. Moving on to vectors. This is the kind of old collection class that you're probably familiar with from the Lotus.Domino classes. If you are working with Java and you're not aware of the build on site, then really, if you're using Java, you should be using the build on site for how to use certain things. It's an excellent resource. And one of the quotes from there, from one of the pages around vectors, is that vector is present in the earlier versions of Java as a legacy class. It tends to not be used as widely now, although there is a reason why it may still be used. From what I could see on C, there is no vector class that's commonly used in C, but there is a vector class that's used in C++. And also, as I've started playing around with Rust recently, vectors are very heavily used in Rust. It's worth bearing in mind, though, that the naming doesn't necessarily mean that it's exactly the same. It's just the same name and concept. Implementations will vary across languages, though. The more common collection that tends to replace vectors in Java is ArrayList. But there are actually differences between the two. ArrayList can't be used across threads. Vectors can. They are synchronized across threads. They're not the only collection type that you might that you can use for synchronized processing, but they are cross-thread. They're thread safe for that. When you get to the limit of a vector, it doubles when it resizes, whereas ArrayList only increases by half. So ArrayLists are better performant for that. ArrayLists, you can only use iterators to iterate over. Vectors, you can use iterators and enumeration. Most of the time, though, iterators are fine for what you would need. As a result, then, there are benefits for using vectors, but they're not really benefits that you would need to leverage for Domino development. So I mentioned iterators and enumeration. Iterator, you do vector.iterator, and while iterator.hasNext and iterator.next. Enumeration, then it's vector.elements, and while e.hasMoreElements, e.nextElement. As we'll see when we go on to streams, there isn't really a need to use either of those now with Java 8. So now we're coming on to the broader collections classes. This whole webinar came about because of some discussion late last year, where I did a blog post years and years ago on Java collections, because I came across this second blog post which had a PDF which I regularly refer back to on what collection to use for what purpose, because there are a lot of different collection types in Java. For someone like me that didn't come from a computer science background, it can get quite confusing. And that PDF is very useful for just easily identifying which ones do which and which ones are what you would want to use for a particular purpose. I've also pointed out got the link here to Beldung's tutorial on which collection type to use for what. That adds some additional information on performance of each using big O notation. So that's worth looking at as well if you want to really understand how they scale depending upon the size. But collections, we have the base type of collection, and then we have three different types of collection, three additional interfaces. So we have lists, sets, and queues. A set cannot have duplicate values in. A list can, a set, they're all unique. That shouldn't say no uniques, that should say no duplicates. I'll fix that. And then a queue allows first in, first out, or last in, first out processing. That can be particularly useful if you're wanting to do recursive processing. So you add an element to the end of the queue, or it actually becomes a stack then if it's a first in, first out. And you just keep taking the first entry out, and when you get to there being no more entries in there, you've iterated over everything, so you can't get into an infinite loop. Then you can just keep doing the recursive processing until there's nothing left on the queue. Maps are completely separate. They have keys and values. Lists, sets, queues, all of those collection types can only contain a single value for each element. So the most common type that you would use for collections, as I've mentioned before, are array lists. These are ordered on insertion order, can contain duplicates. It's good for adding and removing at the end, and it's good for getting access at getting an entry at any particular position in the collection. When it comes to maps, the typical type is a hash map. This is unordered. It's got key value pairs, and obviously it has no duplicate keys. So the array list uses add, the collection uses put. A good tip here to bear in mind if you've been using Java for a long time is you'll see that we've got the interface map and list as the first, as the declaration here, and the type that it contains, that should be map string string actually, the type with the interface, and then the implementation then doesn't reproduce the type, and it defines the actual type that we're using, array list here and hash map here. This means that you're not reproducing the contained types in the array list and map twice on the line. Makes the line a lot shorter as well, and it means that if I wanted to change this at a later time to be a tree map, I don't need to change tree map in 2 places. I can leave map at the start of that line and just change hash map to tree map. So as a style point, it's worth using that particular kind of style. So just to reiterate on those, collections can't have any keys. If you want keys, then you need to use a map. If you want insertion order, then lists are the best thing to use. If you're looking for first in, first out, or last in, first out processing, then queues are better performant for that. And if you're looking for unique entries, then sets are the thing to use. So the 2 types of lists that I use, and it's really these 2 types that I use. Array list is the first one, and linked list is the second one. Linked list is actually a queue as well. So as well as having add and add as an index, it also has add first, add last, get last, remove first, remove last, pop and push. So linked list is better for adding and removing at any particular position. It's worse though for random access, for getting the nth entry. It's going to be better for iterating over the whole collection. And sets, there are 4 types of sets that I commonly use. Hash set is used for just random. That's a basic type of set, just for randomly accessing individual elements out of it. And it stores them based upon the hash of the value. Linked hash set is best for insertion order. It's basically a hash set with a linked list to hold what position each element is at, and so it's good for iterating over them in order. If you want it sorted in any way, then hash set and linked hash set won't do that for you. You need a tree set. And the other thing that Jesse reminded me on for this tree set, you cannot put null values in as well. So it can be particularly useful for that. The 4th one is specifically for enums, and that's an enum set. And we'll come on to an example of that when we get into the demos. Queues, 2 types of queues there. Linked list is the generic catch-all option. It's a list as well as a queue. Array deque is a double-ended queue. That makes it faster than a linked list. It's specifically designed for handling, getting the entries at the first and the last. So those are our 3 types of collections. Maps are then the other type that we would deal with. Hash map again, the default choice, linked hash map. It like the linked list, that gets insertion order. So if you're particularly interested in the insertion order and iterating over everything in order, then the linked hash map is the best one for that. Tree map, again, like the tree set, is sorted, but bear in mind that it can only sort on the key. You cannot sort a tree map based upon the values. There's another less commonly used one, which is weak hash map. That then means that any keys that aren't referenced can be garbage collected. So it has better performance than for if you're adding and removing elements from the map. Now, all of these can only be used in a single thread. They can't be used across threads. Now, typically your Domino usage will not be cross-threaded at all. The only time that I've really used cross-thread functionality is in an OSGI plugin, where I'm wanting to keep a track of the number of references to number of REST service calls, for example, across threads, or I'm wanting to keep a single collection of keywords or something like that that's being used across all threads. Then you need a different type of collection or map. And as you notice, they all start with concurrent because they're all for cross-thread use. So concurrent skip list set, that's an equivalent of tree set for using across threads. Concurrent hash map for that's the equivalent of hash map. Concurrent skip list map, like the skip list set is the equivalent of tree set. Skip list map will be the equivalent of tree map. And concurrent linked DQ is the thread safe version of the linked list. Okay, so that's a lot of stuff, but let's now dive into some examples, and we'll go through some demos and we'll see them in action. And this will hopefully make things a bit easier to understand what it's doing. So we'll start off with the array list. So the array list here, I'm creating an array list, adding entries. So I'm adding 12, then 5, then 15, and adding 100 at index 0. So it will put 100 at first, and it's using, and then it's adding 12 onto the end. And then I'm just using a for each loop to iterate over the collection. Now, the syntax here may be unfamiliar to some of you. I'm using this double colon. This is basically the equivalent of take each element from the for each and pass it into the print line function for system.out. So it's the equivalent of system.out.println lm, where lm is the element that we're passing in. It makes your code much briefer, it's less typing. It does take a bit of getting your head around, but once you're used to this double colon syntax, it's a much preferred way of coding. So if we run that, then we see that 100 was added at the start, and we've got 12, 5, 15, and 12. We've got those duplicates in there. And as we see, it's just on insertion order there. Tree map is the one that allows us to, sorry, tree set is the one that allows us to sort. So by default, tree set will be sorted in alphabetical or numerical order. So what we would expect from this is that it will output 1, 5, 12. It will ignore this 12 because it's already in there, and then 15. We can change the order so that the whole thing is reversed with a comparator. So we don't actually have to create an instance of the comparator. Comparator.reverseOrder will do that for us. It's a static method that creates a comparator to compare in reverse natural order. So this time we should get 15, 12, again just 1, 12 because the tree set doesn't have uniques, 5 and 1. When we run that, focus in the wrong place, I think, yes, then that's what we get, 1, 5, 12, 15, and then reversed order, 15, 12, 5, 1. So that's fine for primitive values, but if we're wanting to do a tree set with objects, then we can't just use that kind of natural ordering. We need to use a comparator. And that's what we've got here. We're creating a new person object. And our person object takes the first name, last name, and age. And we're adding that person to the collection. And then for each, we're calling its toString method, which just prints out the values, just returns them all as a string. Now, when we're doing a comparator, we do comparator.comparing, and this comparing method again is a static method. We can see the S here, meaning it's a static method, and we pass in how it should compare. And it should compare using the person class and the get first name method for each. Again, it's using that double colon syntax. So it will pass in the person instance and call its get first name method and compare using that. So what we see with this is we get a simple ordered list based upon the first name. Now that's fine for this kind of thing, but we might want something where we want to order it on first name, then last name, then age. That we need to get things, we need to make things a bit more complicated. So with this comparator, if I run this now, we'll see that we're adding John Smith, John Doe, Jane Doe, John Doe with a different age than Steve Smith, but we haven't got those because we're comparing it just on the first name. So the only John that we've got is John Smith, the first John that was added. Even though these are actually different people, it's comparing it just on the first name. And so it's stripping out all of the other Johns. To compare it and actually get the correct or the expected option, we need to use a different comparator. So now we're using comparator.comparing first name, but then comparing on last name, and then comparing on age, but telling it to compare on age with reverse order. So what we get now, we get all 5 of those entries because it's checking them on first name, last name, and age. And they're being sorted on first name first, so Jane comes first, then the Johns, then Steve Smith. Then on last names, we get the John Does first and then John Smith. And then on age in reverse order, so we get the eldest John Doe first before the younger one. So creating a comparator for a tree set, it may seem complicated for a start, and you could create your own comparator, but using comparator.comparing, we can actually make it much simpler, much less code. We don't have to create a comparator class and set all of its options. We don't need to set a compare method on the person object itself and tie the implementation for how we want to compare it into the class itself. We can just use comparator.comparing and build it all up so that the comparator is tied to where we're actually doing the processing. So those are our sets, and I mentioned the enum set as well. So we're all familiar with this enum for a message box in LotusScript, and if you're using message box in Java, then you'll need to pass in an integer, and you need to remember what those options are to work out what has actually been passed in. An enum makes it much simpler. One of the problems with passing an integer in is that the allowed expected values for the integer will never be the same as the possible values for an integer. An integer can go much higher than the expected values. Using an enum means that you can prevent people entering values that you don't deem to be acceptable, and it allows you to control what can and can't be entered much more easily. So I'm creating a message box and then doing an enum set of OK cancel and icon stop. So it's using OK cancel 1 and icon stop 16. So I'm then going to print out the total for them, and we can see that that's 17. Enum set takes enums. It can only take enums. You can also use, as well as enum set of, you can also use enum set.all of or enum set.none of, and then add the enums to the set. But enum set.of is the easiest option there. And onto our maps. So our hash map is the simple option. Here we've got map.put and name and then a person. And then the for each for a map is a by consumer. So the for each for an array list is a consumer. A by consumer is a consumer that consumes values but consumes 2 values. Obviously for a map, it's the key and the value. So there we can't use the double dot notation as easily when we're doing the printout. So we use a lambda. It's 2 ways of doing the lambda. If you've got a single parameter, then you don't need the parentheses. If you've got multiple arguments being passed in, then you need parentheses. Then it's the arrow icon, and then system.out.println K for the key. Key is a string already, and value.toString. Just to point out, this is a hyphen and then a angle bracket. Just to point out, the font that I'm using here is not that one. Come on. Close and fonts. JetBrains Mono. I would highly recommend that you download that from the IntelliJ site and set that as your default. It's a much nicer font for coding, and it means that that automatically converts to a nice arrow symbol. So if we run this, then we're outputting the name hyphen and the toString value. So map, tree map is then the ordered option for that. Again, as I said, tree map can only be ordered on the keys. So I'm not creating a comparator to do anything fancy here. It's just going to do natural order on the names. So we get Jane Doe first, John Doe second, and Steve Smith third. So those are our collections and maps. Streams. When you're wanting to process a collection or map, you can do that for each. You can iterate through the collection or map and do things, but Java 8 added streams, and really these are the thing to use. There are 3 steps with the stream: a data source, then 0 or more intermediate operations, and a terminal operation. The thing to bear in mind here is that the intermediate operations never get processed unless there is a terminal operation. And they only get processed when it hits the terminal operation. So data source, mylist.stream, with a map, the data source is either the keys in key set or the key value pair using entry set. Then you've got the intermediate operations. Filter to strip entries out of the stream or to only include entries that match the filter. Distinct will ensure that only unique values are left in the collection or map. Map, this is confusing, and this confused me for quite a while with Java streams, and it still does. This is nothing to do with map classes. This is to do with mapping the incoming value to an outcoming value. It's basically a transform. Flat map is if you've got a collection of collections or a map of maps and you want to transform the values but flatten the whole thing into a single level collection or map. Each of those methods then takes a lambda or the double colon syntax. And then the terminal functions, final functions, are for each, which we've seen being used just on the collection or map. Collect returns a collection, and the most common one there is collector.toList. That means that it collects all the values into a new list. Count returns the number of elements, and reduce merges all of the elements in the collection into a single object. So that would be done, well, we'll see an element of where that can be done. And toArray returns all of the elements just as an array. So collect and returns them as a list. toArray returns them as an array. We actually already had a sample stream, and this was when with our message box when it was using getOpts.total. So this was actually using a stream. First line is passing in the data source, so ops.stream passes the tree set, enum set sorry, of options into stream. That's our data source. Map is then the intermediate operation. So map is passing each enum into the transforming function. Each enum was a message box option. So the transforming that we're doing is to call the getValue method on that enum, which returns its value. So MB_OK was 1. And then we're doing a reduce. That's our final function. And that takes 2 parameters. The first is the initial value that we want to start from. So obviously we're totaling them, we want to total from 0. And then the function to process with each element. So we're using integer.sum. So we're using the double colon notation there. We're passing each value into integer.sum and totaling the overall enums, which is how we got the 17. So that's a sample of a stream. At some point, you will need to debug what's happening with a stream. There are 2 ways to do that. The first option is to use peek. This allows you to peek into that stream at that point in the process. So here, after the filter, we're printing out a filtered value. After the map, we're printing out the transformed value. It still needs a terminal operation. The stream does not get processed until there is a final action, and that's our collect at the end. We'll see that in a bit more action when we see an example of peek in the demo. The other option is actually setting a breakpoint. Breakpoint, if it's a single line lambda, won't stop there. You can either convert the lambda or the double dot notation into a multi-line lambda. So that requires the curly braces around the lambda function, or you can call out to a separate function and put your breakpoint in that. So let's see some examples of those. So here's our array list, and we're adding multiple values to it. And we're going to stream it. We're going to filter it on even numbered elements. The %2 is like mod2 in LotusScript. We're then going to sort the result. We're then going to ensure we're going to take out any duplicates with distinct. And then we're going to map each integer to a string. And then we're going to, our terminal function at the end for each is going to print those out. So out of all of these, we've got 12. It's ignored 5 because that's odd, 15 because it's odd. We've got 100. We've got 8, ignored 20, ignored 99. We've got 20, and it's ignored the duplicate 12. When we go through and add in the peak, we see some interesting things. So if we run that again, we've got start 100 because 100 was the first element in the array list. It was put in at element 0. Start 100, filter 100, start 12, second one here, filter 12, start 5. Filter filters that out so we don't get the print for the filter. Start 15, again filtered out, start 8, filter 8, start 99, filtered out, start 20, filter 20, start 12, filter 12. It's run this part first. And then separately from that, it runs the sort. And so now we get the sort, but we also get distinct and completed. Sorted 8, distinct 8, completed 8. It's run the rest of the processes then together. Completed 12, sorted, distinct, completed 12. Because it's running through the sorted now, this 12 that was at the end is processed next. The duplicate 12 is processed the second time, but we just get the sorted. It's then removed at the distinct. And then the other options as well. So you can see what's happening in which order, and you may well change the order of the intermediate options to process it more efficiently. So if we had the distinct in first, it would filter those out before going on to the others. Sorted may work differently in different positions. It may run on fewer loops. So that looks quite a complex one. When we come to a map, then we'll see it's a little bit more complex with this one. So we've got our map with John Doe, Jane Doe, Steve Smith. We're populating the map, populating the stream with the entry set. So each element is a key value pair. We're then filtering on ent.getKey contains D. So it will filter out Steve Smith. We're then calling the get value on the map. So we're only getting the person objects. And then we're using collectors.toList to collect those into a person list. We're then streaming that list of people, sorting it on age, transforming it with the map function to person.toString, and printing out the result. So we've got two streams here. Oh, focus is in the wrong function. But we see that it's now sorted on age and filtered to filter out Steve Smith, sorry. So in order to sort the results, we need to get a collection from the map first. So other languages, JavaScript, the JavaScript that you're used to from Notes and Domino has arrays and objects. ES6, ECMAScript 16, ECMAScript 2016 added sets and maps. Now, they're a bit weird. They seem to have been copied a bit from Java, but changed slightly. Set, again, is unique values. The for each gives you a callback for each element. The values gives you an iterator for all the values in the set, and then you can iterate over those. Map, again, is a bit strange. It's got set and get. It hasn't got put, which you would expect from other languages. Again, the for each gives you a callback for each key value pair in the map. Entries gives you an iterator where each element is an array, where the first element is the key and the second value is the value. Rust has a standard collections class in similar kind of way, and you'll see a lot of similarities here to what we saw with Java. Vec, an abbreviated name for vector, is the standard one. VecDQ is our double-ended queue of a vector. Linked list is our ordered list. Map, we've got hash map and B-tree map. So hash map and B-tree map for a sorted map, and sets, hash set and B-tree set. LotusScript, when it comes to maps, we're familiar with lists. If you haven't heavily used lists, they are extremely performant. My predecessor at Intech converted some code that was taking hours to run overnight, and by changing it to use lists, cut it down to about 20 minutes. They are extremely performant for large collections. The key is a string for that, and we just need to remember to erase the list at the end of the processing, calling the erase function. There are other options for LotusScript. Evan Olsen put together, he's had for a long time a lists and collections classes, which we used for Domi. The link here is off to Domi for that. And more recently, Andre Girard did some blog posts at the end of last year with classes for large arrays, queues, and stacks. Lists and arrays have some quirks to them in LotusScript, and so when we were working on VoltScript, we were conscious that people who built up that history of LotusScript are going to be familiar with those quirks, like How do you find out how many elements there are in a list? Well, you need to iterate the list. How do you find out whether a list is empty, for example, or whether a list has a particular element? There are some quirks there. So we created collections and map classes, and obviously each element of a map is a key value pair, so we've got a pair map. Unlike the approach with Java, we went with single classes. So the collection class covers all of the hash set, linked list, tree set, array list, all of those. It's insertion order by default. You can pass in a custom comparator, which will be used for matching elements and for ordering elements. The third parameter that it takes is whether or not the collection should be unique. And the fourth is whether or not the collection should be ordered based upon that comparator. So there's four parameters. The first is the type that it contains as a string. Second one, the comparator. Third is whether or not it's unique. And the fourth is whether or not it's sorted. And then you can iterate it. You can get elements by a particular position. You can get and remove first, get and remove last. Maps, we did a similar kind of thing. This takes 3 elements because the keys have to be unique. So it's a string of the type, a comparator, and whether or not it's sorted. And the map, basically the keys are a collection there. So our focus with VoltScript, this is running middleware. So our focus is simplicity and flexibility. You've got to get the data in there from somewhere remote. You've got to pass it on to and somewhere afterwards. So optimizing performance on processing a large collection is not going to have as much impact as minimizing the amount of data or optimizing the data transfer, optimizing the connections over HTTP to the middleware and to the end system. Again, we then use a streaming approach. You have a filter class, which has a filter method, and a transformer class, which has a transform method. And similarly, maps have collect keys and collect values to get a collection. So hopefully those will be of a lot of interest and value to people when they start working with VoltScript in Voltmex Go. That's everything from me, apart from some useful links here to if there's anything more that you need particular information on, then I would recommend searching and looking for a tutorial on Baildunk. It will give you all of that information that you will need. And that is everything from me.
All right, Paul, I will just flip back then, and here we go, and pop up our questions panel again. And remind everybody that we're in Q&A now, and you can ask your questions in the Q&A panel. What did I do? Back there. Oh, rats. Give me just a second here. Oh gosh. There we go. Now you can see my homepage. There. Okay. Use the questions and answer panel. We do have a couple of questions here. The first one is off topic, even though it's appropriate for Paul, but it's a question about installing REST APIs. I'm gonna, Keith, ask you to check out the Keep Domino REST API documentation, because it explains very well how you need to go about that. And Paul, you could always follow up separately if you wanted to, but
Yeah.
we do want to try and keep on topic with our questions and answers here.
And there's also the channel in OpenNTF's Discord as well.
Absolutely, yeah. Head over to the Discord. So first question, you mentioned being sure to erase a list in LotusScript when finished. Does the agent ending not reclaim the list space in memory if you don't do this? And that's actually a question that I have too, so pretty appropriate.
I think it probably does. It probably should. But bear in mind also that the life of LotusScript code varies. In an agent, it's the life of the agent. If you're using a list in a script library and that's added into a form, then I don't think the script library is disposed of until the document is closed. So that list may well get created in query open, for example, maybe finished with in query open, but if it's not erased, that's still in memory for the whole of the life of that document, for example. And similarly, if it was in the initialize of a script library that's used in a view, then it's still around for the life of the view. So best practice, I always erase.
Yeah, actually, that's a really good point, because I think we all have users who tend not to close tabs, whether they're views or documents, over time. I've certainly run into a few people who've complained about application performance, and when I show up, they've got 40 tabs open on their desktop. Good answer. Okay, and Bob has thrown in a question here. This is X pages, but JavaScript collections being used in server-side JavaScript in X pages. What are the limitations or the kinds of collections that you talked about? Can we use them in server-side JavaScript?
So server-side JavaScript is not JavaScript. It is a string that's run within the Java engine. I've been doing some investigation recently into javax.scripting, and it's basically the same kind of thing. It's a string that is parsed with a scripting engine in a Java context. So yes, you can use all of those Java collections and maps in server-side JavaScript. I have no idea what performance is like, but yeah, it's server-side JavaScript is a strange beast, but it's Java under the hood. The
Jesse,
good news with the collections and maps is that they are part of core Java, so you don't need to run through any of the import package options.
Right. Okay, and Michael asks a question that is on the border of we can't answer that question because it's up to HCL, and neither of us, Paul, myself, have information on when that's going to happen. The question is, does HCL have a timeline for when Designer will support ES6 syntax, etc., in the Designer IDE? Currently, a syntax error is raised when trying to use ES6. Paul, unless you want to jump in on that, I was going to say we do know that Designer is on the roadmap for some updates, but from a timing standpoint, that's still in the future.
Yeah, I've no idea. Not my area of business at HCL, I'm afraid. So I'm not involved in any of those discussions. And
Right.
everyone out there has more ability to influence than I do. So
Yeah, well, I was going to say we know that I'm pretty sure that's under Tim Clark's umbrella of things that he's paying attention to, and I know Tim is aware of those kinds of things. I haven't talked to him specifically about supporting ES6, but I would be really surprised if he wasn't aware of that as a requirement or something at least on their wish list to implement.
yeah. Similarly, actually, from a VoltMX Go point of view, from Foundry, the middleware of VoltMX, you can create custom REST services with Java, JavaScript, and in the future with MX Go with VoltScript. The JavaScript there is just running in the JavaX scripting engine using Nashorn, and that doesn't allow ES6 either. So yeah, it's worth bearing that in mind.
Right.
What that possibly also means is if that's a limitation around Nashorn, then you probably wouldn't be able to use ES6 functionality in server-side JavaScript, but then you just go straight to the Java classes anyway, I guess.
Right. Okay. Yeah, and actually, it occurred to me as you were talking about VoltScript that we'll want to have you back when that's ready for prime time and get a little tour of that in one of our upcoming webinars.
Yes, yeah. We're already sounding out a few people. You'll have seen that I posted in the OpenNTF Discord a couple of weeks ago. We had a bit of a deep dive with a few people on the LSXs. At this point in time, we don't have a firm date of when a preview will be available, but it will be post VoltMX Go London delivery, so over the summer sometime.
Excellent. All right, that is our list of questions. I'd like to say thank you very much to Paul and for everyone that joined us today. Again, we've talked about it a bunch, but reminder, Discord is the place to go to interact with us on a regular basis. We're all more or less logged in during the day, or at least to some degree, and you will tend to get your answers quick if you post them in there. So we invite folks to head over there. A reminder, our annual general meeting coming up in a month. Look forward to having the community join us there. And until then, take care and enjoy the rest of your day. Thank you, everyone.